So here we're still looking at exponential equations. We're still looking at terms as a list, but we're gonna move on to a little bit harder topic now. Here I'm asking, I'll give you a list, 4, 8, 12, 16, 32, and then it continues on and on and on. But I'm asking to find a 12. Now what that means is find the 12th numbered on the list. We need to find out what the ratio is, what is the number that I'm multiplying over and over. The ratio in this case, I'm gonna say for number 17, the ratio, I'm gonna choose any number from the list, any number. In this case, let me choose the second number, just to choose a number. I wanna choose 8, and I'm gonna divide it by the number that comes before that. Right, so I'm gonna go 8 divided by 4. So I'm gonna say my ratio is 2. What the ratio tells me is I'm multiplying 2 over and over in order to come.
I don't know if you want.
I'm multiplying 2 over and over in order to come out to with the next term. So the ratio is 2. Now I can do this the long way, right? There's 4 numbers. I can multiply 32 times 2 to come out with the 5th number, the 6th number, the 7th, the 8th, the 9th, the 10th, all the way to 12. That's the long way. And like I said, it's doable. It is doable. Not quite the way I want to do this though. One interesting part I'm going to find out is that let's just call ace of 1. Ace of 1 is my first number. Ace of 1 is just basically 4 multiplied times 2 0 times. It's just the 4. I'm going to say ace of 2 is my 4 multiplied with 2 1 time. Notice my second number, that's basically what it is. I'm going to say ace of 3. My third number is 4 multiplied times 2 2 times. Right, if we figure out 2 squared times 4, okay, so it works. I'm going to say ace of 4. My fourth number on the list is 4 multiplied times 2 3 times. Right, because I start multiplying by 2 on the second number. So notice how my first number I said multiply by 2 0 times. And I said on the second number multiply by once. One interesting part I want to emphasize, this little number with the exponent. Notice the number I'm looking for is 1 bigger than my exponent. Yesterday, I introduced you guys to the equation. I remember I mentioned ace of n is equal to my first number times the ratio, and then I had an exponent n minus 1. You notice it is my exponent, the value of my exponent is 1 less than the number that I'm looking for. So I'm going to do this the short way. Like I said, I don't want to multiply 2 over and over and over. And I'm going to give you guys a thing for today. The answers are going to be pretty big. We're going to be in the thousands. Most of them are going to be in the thousands. The numbers are going to be very, very big. I don't want you to do it the long way. And so the long way is find literally find the 12 numbers. That's a long way. The way I'm going to do this, ace of 12, the 12th number on my list is going to be 4. 4 is my first number times 2 11 times. That's actually how I'm going to find this out. Like I said, I don't need to find all 12 numbers on the list, the first 12 numbers, but I'm going to go 4 times 12 to the 11. Now, 1 times 2 to the 11, the 2 is the ratio. I need to use my calculator. You guys should be able to use a calculator. You guys should know how to use a calculator. So I'm going to say 2 to the 11. Like I said, use a calculator. Find out how to use how to type it in. If you need help, ask me. So I'm going to go 4 times 2048. The 2048 is basically 2 to the 11th, right? My ratio is 2. I had to raise it up to the 11th power. Now, when I multiply these two numbers, 4 times 2048, my answer will be 8,192. I said your numbers, your answers will be in the thousands. Now, I mentioned before, thousands, when you type it in your homework, when you type it in your answers, the comma that separates the thousands from the hundreds, optional. If you type it in, it's correct. If you don't type it in, you're still okay. Now, let me take a look at number 18. I need to find the ratio first. I need to find out what's the ratio. And for me to find the ratio, the number that keeps on being multiplied over and over and over, I'm going to do division. I'm going to choose any number from the list, and I'm going to divide it by the previous number. So I'm going to choose the second number. 4 divided by the number that comes right before that. So 4 divided by 2 is going to give me my ratio is 2. So for me to find A's of 9, I'm going to go 2. That's from my initial number. 2 times 2 to the 8th. Now, this other 2 is the ratio. The one number that has the exponent is the ratio. The number that doesn't have the exponent, that's the first number on my list. All right, so I'm going to use my calculator, and I'm going to say, all right, the number that I'm looking for, it's a 2, because my initial number, now 2 to the 8th. Right? I type it on my calculator. It says 2 to the 8 is 256. Right? 2 times 2 times 2 times 8 times is 256. Now I'm just going to multiply these two numbers, and my answer is 512. I can do this the long way. I can literally come out with the list of 9 numbers, right? 2, 4, 8, 16, and multiply each time by 2 to come out with the next number. I can come out with the list, but honestly, that's the long way. Now, let me take a look at number 19. Let me find out what's the ratio. My ratio, it's any number divided by the previous number. I'm going to go 2, so I'm going to choose a number, 2 divided by a -1. So it gives me that my ratio is -2. So I can tell that in order for me to always come up with the next number on the list, I multiply by -2. So what I'm going to do to find the 12th numbered on my list, I'm going to go -1 times, right? The -1, because that's the first numbered on the list. -1 times, and then I'm going to say -2 11 times. Want to emphasize one thing. I'm looking for the 12th numbered on my list, so I multiply my ratio 11 times. I multiply my ratio always 1 time less than the number that I'm looking for. 1 time less. I'm looking at 12 numbered, so I multiply my ratio 11 times. The reason why it's 1 time less, because I start multiplying from the second number, not from the first number. I start multiplying once I get the second number. All right, so let me find out I'm gonna say, well, -1, my first number is just a -1, right? And -1 is just a -1. Now, -2 to the 11th. I use a calculator, and it gives me -2048. Notice I didn't write my comma on the 2000. Like I said, the comma is optional. I just figured out that it was -2048. Now, when I multiply these numbers, -1 times a -2048 gives me positive 2048. To emphasize that the comma that separates the thousands from the hundreds. It's optional. I'm going to write it this time. I'm going to type it in. So 2048. Let's do one more of these examples. Let me find out what's the ratio. I'm going to choose a -36 because I can choose any number from the list, any number. I'm going to choose a -36 and I'm going to divide this by 12. The number divided by the number before. So -36 divided by 12 gives me -3. Most people like to choose the second number. 12 divided by -4 still gives us -3. Like I said, any number divided by the previous number. So the way I'm going to find out what's my 10th number on the list, I'm going to start with a -4. Because that's my first number. I always have to use, in this case, I'm going to use my first number times -3. I'm going to multiply this 9 times. All right, so let me find out what this is. My -4 is just a -4. My first number is just a number, -4. Remember, I'm using parentheses when I use negatives. Now, -3 to the 9th, I'm going to type it in. I have a calculator and I type this in. -3 to the 9th gives me a -19,683. I multiply these two numbers out. Cool thing, I know a negative times a negative is positive. But 4 times 19,683, my answer gives me 78,732. Like I mentioned, expect your answers to be big. I really don't want you to do this the long way. Like I said, you could, right? I gave you 4 numbers on the list. I'm asking for the 10th one. So obviously find a number, the 5th, the 6th, the 7th, the 8th, the 9th, and then the 10th. You can do it the long way. I don't suggest it, but you can do it. Okay, so that's that. Let me take a look at number 21. This sequence, the way we call this series of numbers, we call the geometric sequence. We're going to push for a lot more in Algebra 2. I know we're Algebra 1 right now. We're taking geometry next, but then in Algebra 2, they use geometric sequence a lot. Geometric sequence is basically when you're multiplying over and over and over. When we graph it, we call it exponential equation. And that's how we're going to call it in Algebra 1, exponential equation. Just for you guys to have an idea, we're going to learn how to graph these. This have a graph. We're going to learn how to graph these. Now, we're going to find, given the term in geometric sequence, in the common ratio. So we already have the ratio. We're going to find the term named in the problem. All right. So I'm not going to give you a list anymore. I'm not going to give you a list. And I'm not going to give you always the first number. In this case, I'm giving you the second number. The second number on the list is 3. So that means there was a number. Then we have 3. And then we continue on and on and on. My ratio is 3. I can find what the other numbers are, right? If I'm going to the right, I multiply by 3. So my numbers, just to have an idea, is 9, 27, 81, 243. Right? I can continue. The funny thing, I can always find the first number as well. I can, instead of going, since I'm going to the left, instead of multiplying, I'm going to divide. So divide by 3. I can find that my first number was actually 1. But I don't need it. I don't need the first number. Instead, what I'm going to do, I'm going to say A of 11 is going to be the number that I give you. Like I said, I don't need to know what the first number is. The number that I give you times the ratio. So the ratio so many times. When I say so many times, I'm going to have an exponent on the ratio. I had 2. I already have the second number. I'm starting from the second number of my list, but I need to get to the 11. So I start thinking, all right, from 2 to 11, I need 9 more times. Let me emphasize this 3, that's the ratio. So the number that I give you times the ratio and how many more times you need to multiply it, right? If you're starting from the second number, you need 9 more times, right? Just think about it. All right, from 2 to 11, how many more numbers I need to get? 9. Easily just subtract 11 minus 2. All right, so I'm going to figure what this is. The number that I started with was a 3. And I'm going to say 3 to the 9th. 3 to the 9. Like I said, I'm using a calculator, so I expect you guys to do the same. 3 to the 9th is 19,683. Now I'm going to multiply these two numbers. So my answer will be 59,049. Expect your numbers to be big. Like I said, we're dealing with big numbers today. Expect your numbers to be big. Let's take a look at number 22. I'm finding 8 of 9. The 9th number in the list. I don't have the first number. I'm giving you a number, 192. I'm going to use parentheses, even though it's not negative. That's the 4th number on the list. So we don't need to know the first number. To be honest, we don't need to know the first number. Have the ratio is 4. So I'm going to multiply that number times 4 to a something, right? An exponent. If I gave you the fourth number on the list, then you're like, all right, how many more times? Because I multiply once to get to the 5th number, to the 6th number, to the 7th number, to the 8th number, to the 9th number. So it seems like I need to multiply my ratio 5 more times. One way that we can easily get there, 9 minus 4, right? Subtract those little subscript numbers. You're starting from the 4th number, so how many more times? Subtract those. 9 minus 4, so 5 more times. All right, let me find out what 4 to the 5th is, because 192 is just 192. 4 to the 5th time, 4 to the 5th powered, is 1,024. When I multiply these numbers, my answer will be, let me write this thing down, 196,608. Remember, I'm always available for tutoring. Always come back if you need help. Always can come back. All right, let's take a look at number 23. I need to find my 9th number on the list. And I'm going to say, all right, I'm going to start with -3. That's the number I give you. And I'm going to multiply this by my ratio. My ratio is -4. I'm going to multiply my ratio so many times. In this case, I'm actually going to multiply my ratio 8 times. How do I know it's 8 times? Because I subtracted my little subscripts, 9 minus 1. All right, so let me find out what's -4 to the 8. I have a calculator, so I type it in. So I'm going to get -3, just -3 times 65,536. -4 to the 8th power, that's what it gave me. Now let me multiply these two numbers out, and my answer will be -196,608. I have a question here. How did you get 1,024? Okay, 1,024. Where did I get 1,024? Was that on my, oh, here. On this question, how did I get 1,024? That was 4 to the 5th power, right? 4 to the 5th power. Kind of like here, -4 to the 8th power is 65,536. Hopefully that cleared your answer, or your question, I mean. Let me do one more example. Okay, good. I did. Nice. Remember, I always read the questions on the chat. If you have questions, feel free to message me. And you're welcome. I will never say your name, but I will read the question and I will respond to it. Okay, so now here I'm finding the 12 numbered on the list. And I'm gonna start with the number given. I gave you a number from the list, a number from the list. It's not always the first number. I'm just giving you a number from the list. In this case, a -2. That number, you have to multiply by the ratio many times. The ratio is a -3. And when I say many times, I'm gonna basically, when I think of an exponent, I see that I'm finding the 12th numbered on the list. And the number that I started was the first numbered on the list. When I think 12 minus 1, because I subtract those numbers, I'm going to multiply my ratio 11 times. Again, I subtracted those numbers. That's how I know how many times I'm going to multiply my ratio. All right, so let's see my work. My first number, my -2, nothing I'm going to do to that number. Now, let me find out what is 3 to the 11th, or -3 in this case, -3 to the 11th. Like I said, use a calculator. -3 to the 11th gives me -177,147. Now, when I multiply these two numbers, the nice thing is that negative with negative is positive, but my answer in this case is 354,294. Like I said, I'm using a calculator. I expect you guys to do the same. We can find the first number and then multiply by -3 to get the second number, multiply by -3, multiply by -3, multiply by -3. Like I said, that's the long way. That's the long way. But you can just use the formula. Notice how my first number is the number given. And I multiply my ratio so many times. The way I find out how many times, in this case, 11 times, the way I find out how many times, I subtract my subscripts. Right? That what I mean with subscripts is those little numbers at the bottom. I subtracted 12 and -1. Let me zoom out. Let me show you guys the work that we did today. Hopefully you guys can take a screenshot. Now, let me stop the recording.